Question 6 is about numerical methods. In part A, we have to show that this equation x minus 4 minus cos 5 root x has a root in the interval 2.5, 3.5. So we have to find f of 2.5 and f of 3.5, and we have to show that there is a change in sign here and the function is continuous. And why does that work? If you would want to know, if we had a graph, a random graph, and it was continuous, if there was a root at this value, suppose I say there's a root at pi. So if I check a value around here which is 3, and I check a value over here which is 4, at 3 this is negative. The y value for this is negative, and for 4 the y value is positive. So if the y value has to go from negative to positive and it is continuous, so the value of y has to go from negative to positive and it has to be continuous, so I cannot lift my pen. If I want to do this, I have to cross the x-axis in between these 2 points. There's no way I can draw this without crossing the x-axis at that point. I have to cross the x-axis to change the sign without the function being discontinuous. The function being discontinuous means that I can just draw this, then draw nothing over here, and continue my my graph here. An example, this would be 1 by x square. So if this is 1 by x square, or 1 by x, my bad. This is negative, this is positive. However, there are no roots in the range because this is discontinuous. I cannot draw this and this without lifting my pen. So f of 2.5 minus 4 minus cos 5 root 2.5, and we'll have 3.5 minus 4 minus cos 5 root 3.5. We'll have to use we'll have to use the radian mode for this. Any function like this, we'll have to use the radian mode. So if you calculate the values, this would be minus 1.44 and this would be 0.497. Then we'll write the conclusion as we'll have to mention both points about the change in sign and the curve being continuous. I can just there must be a root, or now in part B we have to use linear interpolation once to show that to find an approximation of alpha to 2 decimal places. Linear interpolation uses similar triangles to close down on the root. So if we have an equation, In this case, we are given the alpha is in this interval, so 2.5 to 3.5. So in this region, this would be the graph. At 2.5, we know that the value of y for this would be around approximately minus 1.44. For the calculation, we'll be using the exact values using calculator answers. And this will be 0.497. This is alpha over here, the root. This part over here would be alpha minus 2.5. This part over here will be 3.5 minus alpha. So if we consider two similar triangles, this will be triangle 1, this will be triangle 2. You can use any convention. So using the concepts we know about similar triangle, this two will be similar triangle because this and this angle are the same. Both of these are 90 degrees. So this angle must also be the same. So they'll have the same angle ratios. Then we'll have the base of triangle 1, so alpha minus 2.5 divided by the base of the second triangle, so 3.5 minus alpha, and this will be equal to the height of triangle 1, which is f of 2.5, and the height of triangle 2, which is f of 3.5. The approximate values are 0.497 and minus 1.44, but for questions like this, you will have to use exact values. So carry the answer values in your calculator from part A, or put them in the equation we have. So write this whole equation down exactly as it is in your calculator when solving this. We'll have alpha times f 3.5 minus 2.5 times f 3.5 equal to 3.5 f 2.5 minus alpha times f of 2.5. Instead of f 2.5, we'll take minus f of 2.5 because f of 2.5 will be negative 1.44. However, we are considering similar triangles. We just need the length of this or the magnitude of this. We don't need the sign. So we'll change the signs here. So if this is minus 1 f of 2.5, we'll have a minus here, and if we bring a minus over here, this will become a positive. You can put the values in at this stage if it's more comfortable. I'd like to calculate directly, so I'll make alpha the subject at first. So I'll have 3.5 f of 2.5 minus 2.5 function at 3.5 on the right. We can take alpha common out here, so we'll get f 2.5 minus f 3.5. Now we can just subject alpha out. We'll get 3.5 times f of 2.5, which is 2.5 minus 4. Is it minus? Yeah, minus cos 5 root 2.5. Minus 2.5 times f of 3.5. So 3.5 minus 4 minus cos of 5 root 3.5, and on the bottom we'll have f 2.5 minus f 3.5. so this thing over here, this is f 2.5, and we'll subtract f 3.5 from this, so this thing over here. If we calculate this, this will come out to be 3.24 if it's rounded to 2 decimal places. So this is our answer. Now in part B we have to, in part 2 we have g of x, this function over here. In part A we have, in part A of question part 2 we have to find the derivative of g of x. So g prime x would be 2 by 10 x, and then we'll have plus 2 by 2x cube plus 1. If you want further clarification, this is minus 1 times twice x to the power 2. Sorry, this is minus half times x to the power minus 2, and if we differentiate this, we'll get minus half times minus 2 times x to the power minus 3. So we'll get plus x to the power minus 3, which is 1 by x cube, which is what we get here because the 2's cancel out. So this is part A done for question part 2. Now we have the equation g of x equals to 0. We are given that there is a root in the interval 6, 7, and using x not equals to 6, we have to use the Newton-Raphson method procedure to find the second approximation to 3 decimal places here. So 2b, we'll have a note here. There's a formula for Newton-Raphson method that you'll have to use. I think you'll have that in the formula booklet over here as well. If you move to F1, here we see this, we will be given the equation here in under F1. So in further pure maths, in this section we'll have the formula for the Newton-Raphson procedure. So I'll write the formula over here for the procedure. So the formula is xn equals to xn minus 1 plus minus f of xn minus 1 by f prime of x n minus 1. In what we have here, x naught is given as 6. So x naught is 6. X naught would be 6. So x1 here will be 6 minus g of 6 divided by g prime 6. You'll have to use the values in the equations directly to find the exact values. So we'll have 6 minus 1 by 10 times 6 square minus 1 by 2x square. So minus 1 by 2 times 6 square plus x minus 11. So plus 6 minus 11. For g prime of 6, g prime is this expression over here. We'll put 6 in this, so 2 by 10 times 6 plus 1 by 6 cube plus 1. We'll get a value of 6.641, and that's the value of beta. That's it with this question.